Okay, so let's see. I just have to clarify what hat I'm wearing when I'm speaking, because people in the Bitcoin space, some people started companies, some people are investors, and there are different groups of people. There are developers, and sometimes people think I speak for developers. I don't. I speak for myself. Developers can speak for themselves. And so, also I'm a co-founder of a company. Like many other people interested in Bitcoin, we decided to change our careers from working for another startup or another company and start a Bitcoin company. So I'm speaking more as an individual interested in Bitcoin and preserving what's interesting about Bitcoin. So I just thought I'd clarify that. So actually, to understand who owns Bitcoin, if show of hands to get. Okay. Everybody knows what Bitcoin is. So I guess I can basically skip this slide. So very briefly, what is fungibility? So it's a monetary concept that a unit of money should be interchangeable. You shouldn't care about the history of money, where it came from before. You shouldn't get a bad experience where you receive some money and then you can't spend it because it turned out somebody 3 transactions ago committed a crime or something like that. So it's an important concept in money. Most jurisdictions have laws guaranteeing fungibility of money. So now, how does Bitcoin provide fungibility? So that is, so Bitcoin's fungibility is not super strong, but it has advantages over previous systems that had strong fungibility. Namely, the previous systems with strong fungibility were centralized, and so they tended to get shut down or not last very long. And what guarantees fungibility in Bitcoin is basically that mining is decentralized. It means that if one authority in one country decided to ask all the miners they could identify and influence in their country not to mine a set of transactions, well, sooner or later somebody else would mine your transactions. A guy in his garage in that country or somebody in another country. And miners are also anonymous, so it's quite hard to control what they're doing. And so while the coins themselves are kind of anonymous, they are linked because they all have a transaction history apart from the freshly mined coins. So freshly mined coins have much better privacy, but once you start spending them, there's a history, and you get some privacy from the ambiguity between, there's change made because the coin may not have the right value, so then you have to spend a whole coin at once when you look at it in detail. And so when you make a payment, you're also paying yourself change, and that has a side effect of tending to link all your coins together in a wallet, because you'll use a collection of previous change to make a next transaction. And if you can link coins into a wallet, then maybe you can link who's paying who. So continuing types of privacy. So there are a number of different types of privacy that could be interesting to have from Bitcoin. One is identity privacy. So the fact that you can just create a wallet by installing an application, you don't have to fill in a form, so nobody knows as a start who you are. Association privacy, who you're paying, and balance, like how many coins do you have in your wallet, and then transaction value, like how large of a transaction are you making. So today in Bitcoin, that's transparent. You can see all the values, but there is technology to prevent and to hide the values of the transactions. So confidential transactions. At Blockstream, we implemented that confidential transaction feature in a sidechain. It's something that maybe there'll be interest to see in Bitcoin in the future. We're pretty excited about it because it has some trade-offs. It's quite big. The transactions are a couple of kilobytes instead of 100 bytes or something like that for this proof part versus a normal transactions overhead. So that's another example of privacy and fungibility. You get much better privacy and fungibility from a technology like confidential transactions, but it uses a lot more space, and using more space makes things scale less well because you have to broadcast more data around the world. So it seems to me that a lot of the debates about scaling Bitcoin in different ways come down to what do we think is useful about Bitcoin? What's differentiated? So the way to answer that question is, if Bitcoin was offline, and it doesn't happen because it's always on and there are lots of people running miners and so on, but if it was offline, is this transaction you're about to make one that you would not make? You have no other way to make it. And we can think about what those things are. So things like bypassing capital controls, you're not allowed to make the transaction. You live in a country with unstable currency, with hyperinflation, or you don't have a bank account and you want to make an online payment. You want to make a politically sensitive payment, like a donation to WikiLeaks or something. You want some privacy. You're buying something that you don't want to advertise to the world that you're buying. It's some kind of grey market payment, which may or may not be illegal, but in any case, even grey market businesses, which are legal, often have trouble obtaining and maintaining bank accounts, or even transacting with PayPal or something like that. Asset protection, so somebody can't seize your assets if they can't find them. So Bitcoin is good for that too. And it's sort of a combination of features. It's a form of bearer ownership, and that's what gives it self-sovereignty. There's no trusted third party involved in your ownership. So why does decentralization matter in all of this? So that's because I think there are a number of factors, but I think an interesting one is that being able to validate the transaction history is what allows you to not have to trust anybody else, and what makes Bitcoin bearer. Another thing that I mentioned just a minute ago is that decentralization in mining is what makes Bitcoin fungible, guarantees that your coins will be spendable. They won't get blocked as being undesirable or lower fungibility in some way. And a really important one, which is basically a history of why Bitcoin is here, and all of the previous attempts at privacy, anonymous electronic cash are all dead and gone, and that is that decentralized systems are more survivable. There were previous attempts at electronic cash, but they were run by companies with centralized databases, and the companies went out of business or got shut down. With recent developments in China, this is a number of people who had looked at previous generation privacy systems, like Tor and anonymous remailers and so on, considered that it's not hypothetical that a government would seek to shut something down, and so we should care to make it robust in a technical sense. And so I think the action in China, with China officially banning Bitcoin to some extent, I think they're blocking ports and they closed down the exchanges. It shows that it's not hypothetical. So if we have weak decentralization, governments can and will try to influence things. And so if things are very centralized, then there will be side effects. So I talked about self-validation. So I think it takes a while to fully appreciate what the design of Bitcoin does. And one of the interesting parts of Bitcoin is this idea that everybody can, if they want, if they're a power user or they decide they have an interest to do it, they can run a full node. And at the moment, there are about 100,000 full nodes on the Bitcoin network. About 7,000 are reachable, like you can connect to them, but we can infer how many there are for some other aspects of the way the network responds to different types of queries. So 100,000 nodes, and if you're running a full node and you receive a transaction, you're able to verify for yourself without trusting anybody else because you've got the full transaction history. Whereas if you don't run a full node, you use an SPV wallet or some smartphone wallets are talking to a server, you're to some extent trusting the server or trusting the miners or trusting other people to validate. And so you don't really have a bearer asset. If you take it to the extreme and it becomes more and more centralized, then you fall back to a normal bank account situation where you're completely trusting somebody else. So it's important to note that full nodes check all the transactions. Smartphones don't check the signatures. They don't really check much, and they generally can't check much. So some of the smartphone wallets allow you to configure your smartphone wallet to connect to a full node. So you can connect it to your own full node, optionally over Tor. And the Green Dress and Samurai wallets have that configuration option. So it's a nice way to get some extra privacy and to have more guarantees, particularly if there's a lot of activity around forks and you don't know what's going to happen on the network or how well your wallet provider will manage the fork or what decision they'll make. You can use this kind of wallet, and then if it's connected to your node, you'll have control over which network it's looking at yourself. Another aspect is that it's economic nodes are what are important. So if somebody were to just run a node or 100 nodes in Amazon's cloud service, it doesn't really do very much if there's nobody relying on them. What makes your full node secure the network is that if you receive a payment and your full node tells you it's invalid, you will reject the payment, and that will alert other people upstream that something's wrong, right? So if the person you're interacting with tries to pay you and you say there's something wrong with your transaction, and they have a smartphone wallet, then they'll go to their service provider and they say, you gave me an invalid transaction, I want my money back or something. So it's that collection of full nodes that enforces, that provides security on the network. So I encourage full node ownership. It also makes Bitcoin very hard to hack. So centralized systems, there are a few servers run by a few companies like a bank or like PayPal or something. And basically if they were hacked, and it happens now and then, they can create money from nothing, or the hackers can take money from nothing, that kind of thing. But with Bitcoin, to fully hack Bitcoin, you have to hack all the nodes, and there are 100,000 of them, and 7,000, and only 7,000 of them are directly connected online. So it's very hard for somebody to hack it all. And if somebody else gets hacked, and there's something that happens on a Bitcoin service provider's network, it doesn't affect you directly. You still have ownership of your coins. Your coins are in your control. And so if that exchange or other service gets hacked, you will be protected. Hardware wallets are better than software wallets for large amounts, but basically if you've got control of your own private keys, then other people getting hacked doesn't affect you. And so that kind of decentralized verification means that it's not just a few central servers, but everybody's verifying, well, not everybody, but enough people are verifying to provide assurance. So in the example I gave where if somebody sends you a transaction and they're using a smartphone wallet and you receive it and you say it's invalid, you're providing a security service to them because you're alerting them earlier. If nobody noticed for a week, then it could be disastrous. And another thing is putting a Blockstream hat on, we put together a Bitcoin blockchain satellite broadcast network. And an advantage for this kind of thing for the satellite, even if you have lots of bandwidth, it's interesting to use the satellite because you won't be advertising to the peer-to-peer network that your IP address is receiving Bitcoin transactions and running a full node, which is good for privacy. Are you a Bitcoin user at all? And the geolocation of your house. If you're away, maybe somebody will try to burgle and find if the Bitcoins are in the house. Oops. Wrong button. Do you know how to do that? So next thing I was going to talk about scaling. So scaling decentralized systems is more difficult. And that's because Bitcoin, I mean, in general, scaling decentralized systems is more difficult. So if you want to scale a central server system, you just buy a bigger server, you rent more bandwidth. And if you have a peer-to-peer system, it's much more difficult to do that. In the Bitcoin case, command F5. No.
Click on it first. Click on it first. It's PDF.
I hit this by accident. Yeah, I know. Thank you. Okay, back again. So, scaling decentralized. I think it's on autoplay now. Scaling decentralized systems is difficult in general, and in particular, Bitcoin is broadcasting all the transactions. So every full node sees every transaction. So it scales worse than linearly. If you add more full nodes, you get more traffic, and it uses more and more bandwidth. That makes it more and more expensive to run full nodes. Other things that make Bitcoin difficult to scale is that, I mean, it's slow and probabilistic to confirm transactions compared to a central system. A centralized system could confirm a transaction in, you know, a fraction of a second or something. So this is sort of aiming to compare the characteristics of a centralized system versus a decentralized system. It's easy to make scalable, performant centralized systems, but to make scalable and performant decentralized systems is quite hard. And so you can see, well, we can't really control the performance, because if we, you know, reduce the interval between blocks, then all kinds of things would go wrong. You'd get a lot of orphans, the network wouldn't converge. As more resources are needed, it becomes more centralized, and it becomes less bearer because less people can self-validate, less people can run a full node. It makes mining more centralized because you get higher orphan rates, and they have to take countermeasures. So they will start spy mining or start running bigger pools to reduce the latency of transmission of blocks. And as it becomes more centralized, it loses its differentiating features that we skipped at the beginning. Okay, yeah, so so I talked about the fact that as you get, you know, it scales worse than linear. So once there are different, for people who are programmers, you all know about big O complexity, and that, you know, a bubble sort is horrible and quick sort is better, and you've got to choose the right algorithms. But basically, a lot of Bitcoin is n squared or worse, which means that it goes up really steeply, and if it goes up too much, you run out of physical resources, or you cut off certain kinds of use cases, like the ability to run a full node or something like that. So there's a lot of optimization work that's been done in Bitcoin development, which is about improved algorithms or improved implementations to make the scalability curve shallower and allow the system to work with more transactions. I think probably a lot of people don't realize that going back to the early versions of Bitcoin, if you ran it today, it would be unable to keep up. So there's a lot of optimization work that's gone in over the versions to move that forward. And actually, even the 0.15 release that was put out not long ago has you know, a lot of performance enhancements, sort of 40% faster sync, and there are many big percentage increases in performance. So we talked about the trade-off in scalability. So to take a sort of binary case on it, because as I said, you know, as you push scale further, you get centralization, and it has side effects, but it's not a binary effect, right? It's a spectrum. So when we can look at what do we want to optimize for is, well, what is the binary decision? So, you know, today we have the Bitcoin we are interested in, which is permissionless and uncensorable, and that's its kind of unique differentiator, I would argue. On the other end of the spectrum, we could have something that's cheap and centralized, but, you know, I think if you had something that was cheap and centralized, but wasn't permissionless, wasn't uncensorable, wasn't unfreezable, it's not nearly as interesting, and also there's a lot of competition in that space. There are debit cards and paper cash and PayPal. If you have no differentiating features versus them, it's you won't tend to win. And lastly, it's not really necessary, because you can build centralized and semi-centralized systems on top of decentralized systems, but you can't do it the other way around. So as to say, you can build a hosted wallet, or you can build a federated blockchain, or a sidechain with lower security and more centralization, but as a trade-off for people who are maybe doing something where they don't need strong privacy, or don't need high unseizability because it's a small value, or something like that. So another argument is that if we look at previous systems, there is an effect which is a sort of reversion to the status quo. So a topical example is PayPal, which started many years ago as a bearer eCash system on some kind of a PDA mini tablet thing, and it started out to disrupt banking and be an electronic cash system, but it eventually became basically a bank. And actually, in many ways, PayPal's policies are more onerous than banks in terms of having permission, getting your account frozen, and spending 6 months trying to get it unfrozen. And obviously, you need identity to use it, because to open it, you have to often sort of authenticate with a bank account. Now, why they do that? I mean, they don't want to make it like that, but they're centralized, and they're forced to do a lot of things by regulation. So one of the downsides of centralized systems is they're more immediately impacted by regulation. And they're doing it for fraud management, and that's because their payment system is reversible. So they're connected to the regular financial system, which is reversible if there is fraud or enough demand to do that. And so they were forced to deal with the fraud management, and so then they present the users with lots of intrusive questions and will make mistakes in their fraud management. But centralized is cheaper and simpler to scale. So people who are pragmatic and want to provide a service cheaply will tend to build centralized things. But I argue that it's not necessary to do that. You can build things on top or things to one side that do that. But to build those things is work. I mean, it's not nearly as hard as scaling Bitcoin itself, but somebody has to write it, and it has to be secure. And so I argue that this is where the block size debate comes from, which is basically that nobody's stepped up to build those things, the medium security things. And so the people who are using the network for medium security retail things that don't necessarily fully need or have high value from the uncensorability and so on are pushing for the whole of the Bitcoin blockchain to pivot towards something that's medium security and more centralized. Yeah, so that's that. So there is some interaction between privacy and fungibility and scale in another way, which is that, so I mentioned confidential transactions, so they're more fungible, but they're much bigger. So that's a scale impact. Another type of privacy scale thing is that sometimes people will chop coins up into smaller amounts, so they'll make lots of 10th Bitcoin amounts and store them so that when they spend a coin, it's not linked to the other coin, or so that somebody can't tell from, if you put all of your Bitcoins on one coin, then your how much you own is visible every time you spend a coin. So there were some of the old wallets had one address, and they completely reused the address. So every time you made a payment, it would tell somebody, hey, this is my bank balance in Bitcoin, basically. So splitting things up and having multiple coins per wallet, obviously that impacts scale, but it's better for privacy. But in theory, what's creating a privacy problem is the information that allows transactions to be linked. And in some sense, that linking information is extra information that we'd like to delete. So you could say that if we could find a way to delete that linking information, that would actually be good for scalability too, because we wouldn't have to store it and broadcast it. And that's actually what Lightning does. So it doesn't store all of the transactions in the blockchain, it just stores the setup transactions. Then the day-to-day transactions are routed between users, and eventually somebody will close a channel, and that also will go on a blockchain. But all the transactions in between are basically removed. They never get to the blockchain. So what are the technical limits to scale? I'd say the underlying thing is the centralization. If we didn't care about centralization, we could just build a big database and call it a day, right? Or we could put the block size up to 1 gigabyte, and then the only people who could run a full node would be in a data center on like local loop fiber or something. And that would also have the same characteristics as a database, essentially. So what the next limits are the latency, the speed of light. So with the latest block relay networks, it's pretty close to the speed of light. And the latency matters for a number of things. The bandwidth costs and the CPU cost. So to run a full node, your validation bandwidth cost has got to be not too high, or you might hit a bandwidth cap. And as a requirement for the system to be bearer and secure and have the properties that we found interesting, it has to be practical for a reasonable portion of users, if they want to, or their power users or small businesses, to run a full node within a cost that they can cover and with the network bandwidth that's available and types of computers that are not too expensive. So another cost is the, so in the bandwidth topic, the initial sync is 135 gigabytes and growing at 5 to 10 gigabytes a month. And so the initial sync is something that's been optimized a lot historically. It's now about 4 orders of magnitude faster than it was originally, so 10,000 times faster. And it's gone through sort of 10x, 10 times faster performance, rewrites of the sync protocol and that kind of thing, as the sync time grew, and then it got reset back to be faster. I think there's not that much left in terms of sync optimization, but 0.15 had about 40% improvement. Obviously, at 1 megabyte, it's growing around 5 gigs a month, a little bit less, and 2 megabytes, if segregated witness was fully used, it would be more like 10. And so that number is just going to keep growing. So the coin database size, the UTXO size, is also an interesting one. It's the total storage required for the current coins that haven't been spent. The first number is all coins that were ever spent historically, and this is the current set of coins. So the problem is that the database size, it has to be accessed quickly, and so you want to cache a lot of it in memory, and the lookup algorithms are not linear. So as it gets bigger, if it gets twice as big, it will take more than twice as long. Or if it gets twice as big, it will slowly get worse and take longer to access. It's just to do with optimized data structure to store it in. So it talks about latency. If the latency gets big, it starts to add extra milliseconds to syncing the blocks between miners. For a regular user or a wallet, you probably don't mind if it takes 10 seconds for a block to reach you or something to hear about it. But if you're a miner, you need to get it in as few seconds as possible, preferably not more than a couple. So there's a lot of work that goes into fast transmission of blocks, and at this point they are basically sort of network compressed. So the transactions are already sent, and then the block itself is just a description of which transactions that you've already seen belong in the block. So the block, like sort of 1 or 2 megabyte block, ends up being represented in maybe 10 kilobytes of data or less. And so the level of mining centralization also limits scale. I would say if mining was more decentralized, people would be more comfortable about pushing some things closer to the limit. But mining is, I think most people would agree, quite centralized. And with China banning Bitcoin and closing down exchanges and over 50% of mining being in China, That's something which is sort of more top of mind at this point. And what's been seen in the past when orphan rates have increased, because blocks went through different sizes. They were 250 kilobytes, and then they grew to 500 and things like that. That has had impacts in the past, and what miners have done to work around that is they've taken shortcuts, and the shortcuts are typically centralizing. So they will share a pool, so we get bigger pools. They'll do spy mining, which is sort of kind of like a virtual pool. I mean, people will mine on top of a block without looking at the block. They don't even check the previous transactions. They just start mining on top. There's a risk they could mine on top of something invalid, and they have to mine an empty block typically when you do that. So when you see many empty blocks on the network, it's because of spy mining, we think. Yep. So another interesting topic is what are people thinking about how we make changes to Bitcoin. So I think most people would agree that the important things about Bitcoin are there's fungibility, bearer guarantee, that you can self-validate it, that it's uncensorable, permissionless, unseizable, unfreezable, and that the number of coins shouldn't change. And then there are a number of things which are just functionality, like it should be secure and scalable and reliable, be fast and have a good uptime, and be backwards compatible. Now, you can't do all of those things at once, so there are trade-offs. But the way that Bitcoin sort of protocol research and development process works for people working on BIPs or working on different implementations is using the IETF model. And the technical consensus standard is something like there should be no valid technical objections that are not discussed and answered. So, somebody can say, I don't agree, but if they can't explain themselves or they can't give an argument that everybody else says, oh, that's a problem, okay, how do we fix that? Then it should go ahead from a technical level, and then the other level is, what do users think, what do companies think, what do miners think? And as an objective, I think the idea is to improve the system while retaining all of the fundamentals and avoid eroding, so improve fundamentals of functionality without eroding the fundamentals. And it also tends to mean that opt-in things are preferred. So if you have a new feature that's opt-in and has value to a lot of users, but is not interesting to everybody, then people don't seem to mind as long as it doesn't detract from anybody else's enjoyment. So I'd argue we don't need to centralize in order to scale Bitcoin. We have, Lightning is in an advanced stage of development at this point. We can build less decentralized systems on top. And it's, I argue, a bad trade-off to make all of Bitcoin weaker, because then there is no guarantee. You want to build something. You want to build a house on rock, not on sand. So you want a secure base that you can build from, with good guarantees. So,
yep.
Is that done?
Mm-hmm.
Okay.
All right. Thank you. Okay, so we're going to have about 10 minutes for Q&A, so if you can keep your questions a little short, then we can get to more of them. Okay, I saw you first.
Hello, thanks for the talk. I can see Lightning is there mentioned as a scaling option, and then there are others, less centralized systems on top. I would argue Lightning is also the decentralized system on top of Bitcoin. Is it true or not?
I guess it's different. So there is some difference to the requirements as a holder of a Lightning coin. I mean, when you have a Lightning coin, the coin is still the transaction is still a Bitcoin transaction, and if you wanted to, you could put it on a Bitcoin network and claim it. But you do have a new security trade-off, which is you have to monitor the network that the other people involved in the channel don't try and take the money. So I think it's a slightly different security trade-off. Now, centralization, it depends on the topology of the network, but It has some advantages in that it's a sort of automated, lowest fee routed network. So if a particular node were to, say I don't like your transaction, or like block your transactions, try and stop you using it, you wouldn't really notice because the network would use another route, basically, right? And if that party had some of your funds, if you had a one-hop link to it, you could reclaim it on the network. So it is a bit different, but it still has a fairly good bearer guarantee. I mean, my guess is that you would maybe put the amount of money you would feel okay putting on a smartphone wallet in Lightning, and then if you have some savings, you would store them in not in a Lightning wallet, but on chain or something like that. So it would help both, because the transactions the retail transactions that left the main chain and were made more scalable on Lightning would Litecoin. Yeah. So right. So it should also provide competition between on-chain and layer 2. So it should make the main chain less, have more free space or lower transaction fees and things like that.
Yeah, I wanted to ask, wouldn't a lot of the problems with scaling be solved with sharding?
With what, sorry?
With sharding.
Sharding.
Yeah.
Yeah, I mean, the Ethereum guys have talked about sharding, but I think it's quite hard to do sharding securely. So if you're only validating part of the chain, so one idea is that, okay, you chop the chain into 100 parts. So Rusty Russell, who's one of the Lightning developers, before he got involved in Bitcoin, was trying to make a sharded blockchain to see how it would work. And he chopped the chain into 100 sections, and each node in the network, each full node would only validate 2 or 3 shards. But it has a risk, because if you're running a node, you're relying on other people to validate their shards, basically. So it does reduce the security guarantee a bit, and it's also complicated, more complicated. And I guess it's a question for miners. Do miners have to validate all of it? Because the mining scalability is probably one of the worst problems. So it's not clear. If you allow miners, if you make a protocol where miners can mine on sharded information, occasionally the sharded information will be wrong because they didn't validate enough shards, and then they've mined invalid information. So then you have to deal with that as well. So I'm not sure that sharding helps directly. I mean, maybe somebody could make something work longer term. But I mean, a simpler, cruder form of sharding is you just make multiple sidechains. So you make this is what Paul Stortz talks about with the drive chain thing, that you can make a Bitcoin-denominated sidechain. This is a drive chain is a type of sidechain, and you can put your Bitcoins in it. And it's more centralized because it has large blocks. But it's a trade-off, and you opt to use it if that's okay for you, right? And so for many people, it's okay. They're not, maybe just doing casual payments. They don't really need the guarantees. And maybe it's low value. So that's another way to do it, to build things. And a sidechain is also interesting because you can do sort of zero cash like transaction privacy things, which are much more private, but high risk in terms of technology risk, that they might have a technology failure because it's bleeding edge technology.
What are the risks of brute forcing a private key or duplicating a private key?
Very low. I mean, I think it's the least, the previous electronic cash systems were looking to provide only sort of public key, private key guarantees. So they could say that, well, I mean, they make some big assumptions, right, that you trust the central server, but there's a problem with many cryptography things. They make an assumption, and the assumption is not very reasonable. So then you get sort of garbage in, garbage out effect. But basically, if you believe the assumptions, then it's considered to be basically impossible to, crack the private key or something. But of course, you do have to. There are risks like, a bad random number generator, or the key being online and getting hacked, or keeping it physically secure. So the hardware wallets are good. But I think there's not much risk of, direct brute force of keys.
Oh, hi there. How do you think the blockchain is going to be secure when the block reward goes away?
Yeah, that's an interesting question. So, I think there's a couple of answers. One answer is that hopefully fees will pay for it. But if fees are paying, today I would say the scale is limited by technology, like how fast you can sync this block size globally within a second or less or something. And a block size doesn't sound very big, but it's actually quite challenging to sync that much data globally quickly. So today I think we've got those bottlenecks, but in a future where those bottlenecks were overcome by technology that we don't have yet, like let's say provably secure snarks or something that could really minimize the data. A different question would be, well, if we had no technical scaling limit, should there be a limit anyway to create a market for fees? Because if we have an infinite block size, the fees will be zero and there'll be no incentive to mine. So that would be a problem. Another answer that a friend of mine put forward is that maybe businesses that are relying on Bitcoin would do a bit of mining each. So, if all the Bitcoin ecosystem companies like exchanges and payment processors had like 1% hash rate each or something, 100 companies, then, maybe it's not exactly altruistic, but they want this, so they derive value from this system, so maybe they have an incentive to keep it operating and keep it secure. And it's still, it's still survivable because if some of them go out of business, the other ones will take over. And individuals can do some too if they have savings and they want to contribute to security of the network. It's not as good from, today Bitcoin derives security from this factor, right? That we say it's not just that we're trusting 50% or whatever of the miners to be honest, but they don't get paid if they don't do honest work. So they have a financial incentive to be honest. And now that would go away if there are no fees and no reward. So it's an interesting situation. It's a long time away though, hopefully.
So do you think that, is there a way to incentivize miners to mine side chains?
That's another interesting question. So, you can pay transaction fees on the sidechain, and then people can mine to receive those transaction fees. So, but a sidechain brings forward that potential future much closer because there's no reward on the sidechain, only fees, right? So it allows us to experience what that's like today. So I don't think it's scalable, but hypothetically with the drive chain, one sidechain that Paul Stortz is talking about, you could conceptually make it a consensus rule on the sidechain or on a drive chain that some portion of the Bitcoin reward had to be transferred from the Coinbase transaction into the sidechain. So that would be a way to sort of borrow some of Bitcoin's rewards to secure the other chain. I don't know if that would be very popular though, right? Because if you're interested in Bitcoin and securing Bitcoin, why do you want to lose some of that security to a chain that is intentionally making weak security trade-offs? Another answer is that don't put too much money in it. It's it's enhanced risk. It's medium security. It's more centralized. Yeah, I think Paul Stortz has one other interesting thing to say about sidechain. So the failure risk for a sidechain is that the miners, so it has coins in it that came from Bitcoin that are locked up in a peg transaction on the main chain. So he has this, so the failure mode is that the miners could take all those coins, right, on the main chain. They could just take all the sidechain coins and that would be the end of it. And that's because the main chain is not looking at the sidechain rules. So the main chain is just believing what the miners tell it about which coins need to come out. So Paul's argument was that, maybe a way to fix this is to make the withdrawal really slow. So to get coins out of the sidechain, it takes 3 months, let's say. And you can make it, you can hide that slowness by swapping and by doing lightning between them, and so you can overcome it. But the actual underlying transfer is slow. Then it gives humans time to say, "Hey, wait, it's you know, they're making a run at it." It happens in slow motion, so you can do something about it in software. So if they tried that, you know, people could make changes to software and push out an update that blocks this attempt. So I think that could be an interesting solution. I think that's somewhat plausible to me, which is sort of, you know, right. I mean, you still need the sidechain to progress, you know, for them not to reorganize it. So there's trust there, but at least they can't. It's harder for them to take all the coins.
Okay, all right. That was the last question. We're out of time. So thank you again.
Thank you.